Hi, everybody. I'm Cordova, assistant professor and statewide soil health specialist at UNL. I've been in as part of UNL already now 6 months. Has been great, and for me, it's a big pleasure to be here and meeting you all. There are some familiar faces that I can recognize from some of the soil health events that we started to promote, like since early January. And also, it's great to hear from Marty, like, all the knowledge that he shared about like soil pH, soil health, the importance, and also learning more about the project Grow. So actually, it's a big privilege that you guys have here, this outdoor classroom, that you're able to test different ideas, like go crazy, like go wild and do something that probably in your farm you're not going to do, right? You probably will not go like that. Be that aggressive or that bold, trying to play around with different amendments or different management practices, right? So I encourage you to don't give up on that project. So it is a community project, and it takes a lot of time to build up organic matter. So please be patient and also don't expect to see like changes overnight. So as researchers and scientists, we rely on long-term studies to understand the potential of different ideas that they have and their impact that they could lead into. So what we know now of soil fertility actually came from long-term studies in England, here in the Morrow plots, the Sandworth plots in the States that are like actually long-term studies of now more than 100 years, or some others are like more than 20 years. So please don't give up on that project. It is a community project, so I encourage you to get involved and keep, investing other ideas or trying to get funding to keep supporting these. As I see it, this project actually could be self-sufficient, could maintain itself and be profitable probably in the long run, yes, but also it's like serve as your living lab, right? Could be that lab that you could have it like just next door that you can walk in, and you could probably test different parts of that field, like different ideas, different cover crops, different rotations. So I think that, the group that has been working on this project already for years have done like a great job. And you have seen that now young people are like visiting those plots. So also for them, it brings like some ideas, and also they can see like the impact that goes beyond the yield, right? So right now we just like look at different tables of numbers, like the profits, how much they like invested and how much they got it out of that management. But actually, if we start to put some numbers in the other ecosystem services, like for example, like how many birds are visiting those plots, or how many insects do we have there, or like the air quality. If we put some numbers, some money, some dollar signs there, I think that it gets like way bigger than our conventionally managed system. So it is great that we have right now side to side those comparisons. So on one side, you're going to visit this afternoon the conventionally managed field, corn, soybean, and teal. And then on the other side, you will see the plots of Project Grow. And you will see like also how dark is their soil, right? And also probably how fluffy, because like with organic matter, there comes like different factors that will, more benefit that actually that right now with the current system, the economic system that we have in place, we're not putting dollars in it, right? So right now we're hearing about concerns of water quality, right? Like the big effects or the big impacts of like overusing nitrogen fertilizers that, at the end of the day, we're paying bigger bills in the hospital that we are probably getting out of our farm. So that's something to consider. And with that, I wanted to encourage you to keep building and maintaining healthy soils. And now I'm going to tell you why. And some of you probably know more about this. So this talk, I'm going to cover like 3 main points, like the concept, the importance, and the strategy, how to build and maintaining healthy soils. But before we jump into that, I want you to pull out your phones and scan this QR code. Go into this webpage. It's just like, I want to ask you to rank. You're going to find like 7 different categories there. How do you rank the importance of building healthy soils or maintaining healthy soils? So just like pull up your phone, read the QR code, and it will take you directly to that website. So you can if you're not familiar with the QR code reading, probably just when you open your camera, the camera of your phone, then it will pop out like a small link that directly after you click, it will take you to the website of this activity. And you can rearrange like according, or you can vote like what do you think out of those 7 activities, which are the most important? Being one, the most important of building and maintaining healthy soils. So this will tell me about how much you care about soil health, and also how do you see a healthy soil, like what is the importance of building this a healthy soil. So let's jump into the answers. And these are the answers out of 11 participants in this room. So you can see here, this is live results from this very short survey. And we see that for most of the people here in this room, no wonder that, you know, the importance is building and maintaining healthy soils coming from something that we really care is water quality and storage. The second is biodiversity, micro and macro biodiversity. Going in the third place is community physical and mental health. Less in the fourth, and like now we see that they're starting to move around. Food security, we still see it that is in the fourth place, and then less reliance on off-farm inputs on the fifth place. Sixth, economic stability, and seventh, air quality. So this is great to know, right? So water quality right now is something that is the hot topic in the room, right? And we are like highly concerned after hearing from Laura, like all of those numbers and how we are like connected with the ecosystem, right? So if the ecosystem is not healthy, we are not healthy, or communities are not healthy. So I'm glad to see like these other variables too that you have ranked on the top as top priority. Okay. So with that in mind, that's a great assessment, and that, you know, gives me a good perspective of everybody's opinion and how much you care about different resources. But now let's go into the concept of what is soil health. So the term actually has evolved over time, right? And most of you will say like, oh, we talk about in the past about soil quality, or we talk about soil fertility, we talk about soil tilth. But now, like, the soil health actually really needed to like, we really needed to do some benchmarking about this term. And now, like, acknowledging with the soil health that actually a soil health is the capacity of the soil to function as a living ecosystem that can sustain healthy plants, animals, and humans, right? So now we're recognizing that all the living creatures that are in the soil are the ones that are doing all the work of decomposing material, right? Recycling nutrients, and the ones that are like really helping, you know, the plants to like have access to different nutrients, to different resources, right? For example, if we have some, mycorrhizae could be able to uptake phosphorus that is not in an available form. So those microbes will really like partner with the plants, right? In order to get like some nutrients that are not accessible and make them available. So now we're like actually going beyond what is fertility for us. Fertility for us in the past was mainly soil chemistry, but now we're acknowledging that we really need to really pay attention about the engineers, like in the micro scale level, right? All the microbes, all the insects, the mesofauna that is there, that is helping us to actually break down the organic matter, break down all the materials that we are adding into all the residues in the system. So a healthy soil, according to the FIO, is the basis of the food production. That according to them, like 95% of our food is directly coming from healthy soils. Now, the soils also can support, like a healthy soil can support easily over 1,000 species of invertebrates in 11 square foot of a forest soil. So that is a lot of microorganisms. And then also to remind you that soils is a non-renewable resource. So I was just talking during the break that 2 centimeters that are like, in order for the system, for nature to build up 2 centimeters or like 1 inch of soil, it takes 1,000 years. But for us, with like some very aggressive practices in the field, we are easily losing 5 or 6 inches of soil like in 10 years, right? So that's pretty concerning, right? That actually the nature doesn't keep up. The rates of nature of building up soil is like, it takes longer than for us to lose it. So the challenges, some of those we're just talk about. We mentioned about like compaction. Compaction is one of the big issues, and that could be controlled, right? We could control traffic in our fields. We could like probably use less farm machinery on our fields. There could be like probably some management practices, like, I don't know, different crops that will allow us to decrease the compaction of our soil. Another challenge is erosion. So as I mentioned, if we don't have enough cover in our field, and if we were just farming like few months a year, and then the rest is fallow or like, exposed soil, then we're like, that soil is prone to be lost, right? Like from like probably heavy rain or probably wind. So we're starting to see, and I just heard like recently about the big wind that you guys have like just last year, right? That affected the whole community, and there were some instances of swimming pools like replacing their filters 3 times during the summer season, which is not common, right? And then going into the nutrient imbalances. So that's going that either like we are like, having like not enough, or we are having like a surplus of nutrients in our system. So that will also not be that effective for us, right? Because probably we are over applying, and that over application is actually ending up in like pollution, polluting our water wells and so on, or we are like probably even like changing the pH of our system too, right? So I'm going to talk a little bit more about the acidification here. That is another challenge. So someone asked about like ammonium, right? So with an over application of ammonium, that will lead into like more hydrogen ions in the system. And having more hydrogen ions, that decreases the pH dramatically, going to the pH of 5 that Marty just talked about, right? And reaching all the other cations, right? So the other calcium, magnesium, that are also necessary for our crops to grow. And when we're reaching pH levels of like very acidic pH levels, like 5, for example, that will lead into other problems like aluminum toxicity. So, that's, we are like looking into that, building organic matter, trying to keep like, going into finding efficient levels of nutrients, but also trying to, our pH level be at the optimum level, right? Between 6 to 7.5, where we have like some of the nutrients that are necessary for the plant growth are available. So that's something to consider. And then we have other challenges like pests, pathogens, salinity, and sodicity. So also like when we're having like irrigation fields, and we are not paying attention of like, building up calcium or magnesium or sodium. So building up the salinity of our fields, that also leading to other issues, right? So Marty just mentioned, and I think that Marty gave a great introduction of soil health here. That will really lead into like other issues, that soil dispersion, right? The soil cannot aggregate because there's high levels of sodium, and then you will not have like very perfect pore spaces that allow the water and the air to move freely. So then, those are like big problems that we need to deal with now. So rebuilding and maintaining healthy soils, why? So there are like healthy soils have these multifunctionality. So there are like 4 groups. One is soil fertility that you guys are very familiar with. Then we have environmental and climate regulation aspects that benefits from having healthy soils. Also, there are social benefits and economic benefits. So from the soil fertility, we have that a fertile soil or a healthy soil, we have like enough habitat to host diverse living forms. That would also lead into like recycling more effectively the nutrients, and that will promote more resilience, climate resilience. In terms of the environmental aspects, could help us to store and filter and transform these nutrients and the water as well, and sequester carbon, right? That leading to like having a healthy soil will help us to mitigate climate change, right? Reduce the greenhouse gas emissions, reduce that big changes of temperature and so on that we're seeing now for like having too much carbon dioxide in the system. Regarding the social benefits, definitely like the most important one is that it will support the physical and mental health of our community. So don't think that you are like working in an island. We are all connected, right? Like very connected when you are like close to an area like here, York, right? Slightly connected with people from like Lincoln, but we are all connected, right? As humans and also like as a community, but also we are connected with the environment. So as you can see with the water pollution, how detrimental it will be for our like community, the health of our community. Now regarding to the economic benefits, like a healthy soil could help to be like more resilient, but also could serve as a place that can stabilize production, could reduce the inputs and the agricultural production cost. And as I mentioned, like promote the economic stability in the agricultural sector and the commodity groups. Now, soil organic matter is the backbone of a healthy soil, right? If we have enough food for the microbes to work on, keep them alive, keep them active, that is the key of a healthy soil. So the backbone, we should be targeting into increasing organic matter no matter what, right? There will be like some practices I'm going to cover later today. So soil organic matter is the best indicator of soil health. So probably some of you have been doing some testing, sending soil samples for analysis for soil health, and then they're going to like give you like a big list of different measurements to do. But it's kind of hard to pick some of them, and probably sometimes it's pricey to send for this type of analysis, but you will not be grown if you go and test organic matter content of your field, of your soil samples. So just to remind you that, organic matter comes from plant residues or like soil macro and microorganisms at various states of the composition. It is the source of stable and unique organic compounds. Most of the soil organic matter, like around 58% of the organic matter, it is organic carbon. And out of these organic carbon content of organic matter, 95% it is organic nitrogen that is bound to this soil organic carbon. So when you're building up, when you're accumulating or like trying to find or choose management practices that are going to build the organic matter content, you are building both things, organic carbon and organic nitrogen. So the organic matter supports this healthy soil multifunctionality that I mentioned to you. So now how to do this soil health assessment, right? It's more complex that you guys are aware of or trained to do, like soil fertility tests, because this soil health assessment goes beyond that. So what you're like probably familiar with is to test for soil chemical properties and some soil physical properties, right? Like ball density, like texture, like probably some pH, phosphorus, organic matter. But actually, when we are like doing a soil health assessment, we're going beyond that. Because when the typical analysis will only tell you about like your nutrient deficiencies or your excesses. When you're looking into the soil health assessment, definitely that needs to be done like once every 3 or 5 years. It's something that you don't do like in an annual basis. And I'm going to explain why. So the objective of doing this soil health assessment first is to understand what are the constraints beyond these nutrient deficiencies and excesses that you have in your field. Second is to monitor the soil improvements or degradation of the current practices that you have in place. And the third is to assess the farming system risk, right? We're looking into like the long term. So in this assessment, you are going to like analyze if the current practice that you have in your farm is the ideal one to keep running in the same way in the next 5-10 years. So look these as like a way when you are, I would say that when you're doing this soil health assessment, this type of analysis will really help you to look into investments in the long run. So now, as I mentioned earlier, like when you ask the lab, okay, so I want to do this soil health assessment or this soil health analysis, what are the parameters that you are going to measure? Perhaps they're going to send you like a long list of analyses that probably 50 variables that might like add up like analysis of, for example, of $80 per sample. So that could be like a lot, right? So my recommendation is just to pick few of them. The most important ones are highlighted in red. So for soil biology, could go into like respiration potentials and soil proteins. That can tell you how active are the microbes and also how efficient they are. In terms of the chemistry, I'm talking about like earlier about organic matter content. That tells you about the fertility, how fertile is the soil, and looking into the active carbon too. The active carbon is one part that really tells you of the carbon that is readily available for the microbes to like decompose. In terms of soil physical, aggregation stability is key, and bulk density as well. So those, if you pick some of these as the main important variables to measure and assess your soil health analysis, that the price of that analysis will not too high. And you could do like more samples and you can look into measuring different parts of your field. Now, as I told you earlier, some of these variables don't change overnight. I was very impressed with the numbers that Dan shared with us today about the organic matter content from the crop growth, that it changed from 2.8 to 3.5, I think. Exactly 3.2. So that is a lot, right? But also because they are doing like sustainable intensification management. They're adding a lot of amendments, a lot of residue, manure on top of that, right? So in a common farm, actually it takes more than 5 to 10 years to see like changes in organic carbon from like, for example, like a common farm of corn and soybean without anything on top. So just to like remind you that some of these variables might take some time to see changes after you're adopting a new practice. So perhaps like the minimum time will be like 3 years. That's why we are like suggesting to do these assessments every 3 years or 5 years, but not less than that. But there are like other ways to also pick up some changes, immediate changes, and I'm going into that in a minute. So the challenge is an opportunity to assess soil health. So definitely there is a learning curve as everything, right? This goes beyond or like soil fertility test, soil fertility analysis. So definitely here we need to understand the variability that we have in our fields, because we are going to really take into account that it affects directly into our different soil properties. So, and also like all depends on like how deep you're sampling, right? That perhaps for some analysis, you might, like for my soil biological analysis, you might look into just the first 0 to 5 centimeters depth. So that will be like close to 2 inches depth. So my advice of where to sample, so definitely here what you're seeing in this example is that you could follow, I mean, definitely you don't need to follow these as a sampling grid, right? It will take like too many samples and also it might get like very costly. But instead you can pick up like areas from your, let's see, where is it? Okay, so you know your field better than anybody, right? Some of you have some yield monitors, and from here you can like probably zone, like make some split your field depending on the zones of productivity. So you could be like, targeting areas where you're like underperforming in terms of productivity, and some other areas that you're overperforming. You could like pick those areas, but what I'm saying is here that the soil sampling definitely needs to be in a zone in which you take, and also GPS, your GPS marks sampling positions. And that will really facilitate for you to detect changes over time. So you're going back to the same point where you sample. So here I'm suggesting like 10 soil cores in a radius of 5 meters. And of course, you need to like GPS mark your bullseye point of where you're going to sample. And also that will really help you to, when you're coming back to the same spot. So you are decreasing that variability that you will find if you're not choosing the same spot and you are going elsewhere, because we know how heterogeneous is the soil, and that could really impact our measurements and could really be make it difficult to detect those changes in soil fertility or in our soil health assessment. So now, like sampling time, definitely when the soil is moist, go into before planting or after harvest. And why is that? You're doing this sampling when the soil is at a kind of a steady state and has not been disturbed physically, right? Those are the recommendations. If you are, for example, applying organic inputs like manure, mulching, compost, definitely like come and sample 3 months after, because again, like we're trying to find like that spot where the soil is like kind of in a steady state. It has not been like any physical disturbance that has like removed the soil, so that could affect the readings later on. So here's an example of lessons learned of just sampling soils for bulk density. So what you see here, that when we sample after planting, all readings of soil bulk density was like very variable, right? That was something that we were really not expecting, because these are like at sampling depth of more than 100 centimeters. And we see that actually we were expecting something like this. And these measurements, actually we got them after harvest. So this is just an example that in a previous year, like they didn't consider of like what is the impact of coming after like physical distortion of the soil and take measurements. And now we know, right? We need to come like before we do any type of work in the field, or like after like harvest, right? When the field is like completely in a good shape also for sampling. So the sampling frequency. So I mentioned that this soil health assessment is something that we're going to monitor over time, right? It might take, if we change our management practice today, definitely our sampling needs to take place now. That is the baseline before we do the implementation of a new management practice. And then 3 years later, we're coming back and sample on the same spots. And we see how much our variables have changed in these last 3 years of this new management practice. There are like, for example, there are other ways that we can like actually see the changes in soil health if we don't want to wait that long, right? So here are like some examples of, for example, in the case 1, when we're trying to determine the soil health gains after adopting this new practice, is the one that I mentioned, having the reference crop or the reference traditional management, then compare it with a new practice after 3 years. The second case, this is different. This is the one that we are like, the one that we have the reference, the traditional management, having the baseline, and then coming the 5 years later, if we're not doing anything in this system, and try to monitor like what is the soil health status of my traditional system. The third case will be if we have a reference site or like a reference native grassland or a forest nearby, or like a probably some others are like choosing the fence line. that, soils that hasn't been like under ag practices or any type of management as their baseline, and compare it with like what we have like right now after managing conventionally of over like 10 or 20 years. So how far I am from like a soil that was not disturbed, ever, and with my current practice. That really gives you a comparison, a good comparison of how good or how bad your soil health is. So now here is something that I mentioned, but that we are monitoring like the impacts of management, like, in the present, we can go back in the past having your defined reference site, and then looking to our future, right? What is the potential that I have right now? So if my reference line of not having any management, it is, I don't know, 3% organic matter, and my conventionally managed system is like 1.5. So my potential will be like, oh, I can get into like 3% if I reduce the intensity of my management practices and so on. So just consider that it's the big drivers of changing or improving or building the soil health of your system is climate and weather, soils, the management, and also the microbes. The microbes and the different mesofauna are like the engineers that are helping us to actually build these healthy soils. So now this is, here I'm suggesting to download or get like into the website to get like more information that the NRCS has like online available. And here you can learn more about like soil health assessment. You have available the crop planning field soil health assessment guide, the soil quality indicators, and also you can, if you do some rangeland, they also have another guide of interpreting the indicators of rangeland health. So the last part, how do we build healthy soils? So there are like two strategies. The first strategy that most of you are like familiarized are the ones that are like related to the 5 principles of soil health. So it will be like keeping the soil covered, right? Either like with residues or with cover crops. Reduce the soil physical disturbance, perhaps going into reduced till or no till. Integrate crop livestock. Increase the plant diversity, and maintaining continuous living plants or roots. So that's, those are the nature-based solutions for building healthy soils. Now going into the technology base. So perhaps these are like costly, or these like will definitely take some like learning curve, that there will be like a learning curve involved. There are some others that definitely we could like consider about these technology-based solutions. So in our current system, we need to find ways to be more efficient in using all resources, right? Like using fertilizer, using like different chemicals by using this technology, right? Some have like the yield monitors, right? That could tell you about a lot about where are your spots that are underperforming, and where are like the sinkholes where you are putting money, but you're not getting enough profit out of that, right? So those are like sinkholes that you need to consider, that probably those need to be out of production, because you are like, wasting all the inputs and your money there. And probably those could be your pollinator hubs. You don't know. So that's something that, you need to reconsider and learn about, like what is the field. I mean, what is the performance of your field and the different zones that you have there. Another one is to improve irrigation management, right? Perhaps even like just doing some maintenance could really save you a lot of money, but also in the long run, that will also help us to like decrease the water pollution, will also decrease the soil salinity in your field, and so on. So like little changes actually make big impacts when building healthy soil. And also keeping like all your data in place will really help any of these data scientists or like precision ag experts to help you out to understand your field better, right? With like using these engines, these crop models, soil models. So looking at using the artificial intelligence to making decision support tools for the next 10 years, how you will need to manage your field better. So bottom line here, we're looking into using different approaches to be more efficient And by being more efficient is not only in terms of dollars, it's also in terms of building healthy soils in the long run that could be sustainable and could like, leave those fields in good shape for the next generation to take over. So we're looking into like you become more efficient in managing everything that you have in your farm to not only produce crops, but also to deliver other ecosystem services that could benefit us all as a community. So here are some examples about using different practices and how much they have impacted in building organic carbon. So this is a study that I did in Michigan State University before joining UNL. And here they have a long-term study that is now 35 years old. And by the time that I was able to do the assessment using their historical data, they have the corn, soybean, wheat rotation managed in different ways. So they have like conventionally managed with tillage. They have another system like no-till, and another one, the biologically based, that it was mainly the conventional tillage plus cover crop. And then we were able to like look into gains in organic matter or organic carbon, as you can see here, that is, a proxy of organic matter. And we see that here, the conventionally managed system, the organic carbon content was 40 tons per acre. Now, when going into no-till, we found that after 25 years of having this system under no-till, it increased 11%. And then if, the other treatment that was like conventionally managed, but only with the addition of cover crops, it actually increased close to 30% over that time. So this is pretty interesting, and see the importance of having these other systems that you could probably play around with, like either no-till, either cover crops, and you could get creative, right? So probably, as this is a learning curve, you can like start to play with one element or with one management at a time. But you can see that in the long run, these systems are increasing organic carbon and making like self-sufficient. So like these biologically based have been decreasing the need of nitrogen fertilizer over this time period, which was like, very important for us to understand in terms of economics too. There are, of course, other opportunities for storing carbon, storing organic matter. Like we look into like not only cover crops. So here what you see is like how much these different practices decrease or like sequester carbon, so increase carbon in their system. And we see that positive effects, of course, don't get caught up by these negative values. That means just the sequestration of carbon in terms of CO2. So here you see that there's big gains of carbon sequestration in cover crops, agroforestry, and also like, a little bit less in no-tillage. We see that the more plants that we have in our system, the more carbon that we are actually, investing in our soils. Now, the soil health program that we are building at UNL we're just starting to set up our program, and we're looking into our current and future collaborations. We'll be working on cropping systems, definitely like trying to help on the decision support tool, and also like assessing the impacts of cover crops and other management practices that I mentioned that are the nature-based solutions, which are like, livestock incorporation, what is the impact of crop livestock integration, and so on. And then also looking into the precision ag part of the system, right? Because now everybody has a big database coming from their tractors and also from like different soil samples analysis that you guys have been running over these in the last few years or decades. And then also looking at the opportunities of like, looking into the opportunities that we have now and also in the future. We're talking about the carbon market and the economic incentives of different like probably ecosystem services market that probably you will like put some tag on or like add some money into your like income. Last part, I want to invite you to join us at our upcoming soil health events. So some of you already participated in our winter and spring events, but now we are having like upcoming 2 soil health school, one in West Central that is on June 27th and 28th. The other one is at Haskell that is in Concord, August 1 through 3rd. that will be in a partnership with the Soil Health Nexus group. And then we're going to have some field days also, one at NREC on August 22nd. And pending, we have one here in York with Jenny Reese. So with that, I want to thank you for your attention, and I'm happy to take any questions. Thanks. Okay, yeah, go ahead. Sorry.
And where I'm at, drip till is really popular. What do you think of drip tilling versus no-till?
Right, that's a good question. So that's one of the more, I mean, definitely will be in the reduced tillage side group that is recommended in strict tillage, right? They are also recommending now in terms of managing the soils that the frequency. Probably there's not, and there isn't a need to till every year. There probably be some years that, you know, probably it's too wet, or like, you know, the conditions are not favorable, but also will benefit the soil from not being tilled, right? So we are looking into like playing around with the frequency of tilling, right? If someone cannot, you know, go into like full no-till, right? Because the soil also probably, I don't know, depends on the soil texture as well, right? Some soils that are like, you know, mostly clay, definitely, or might need like some tillage, or systems that are like continuous corn, definitely that needs some tillage. So all depends on like, you know, the soil type, the crop rotation that they have in place, and you know, that will be allow the farmer to like probably take a break on tillage, or like go into like the reduced tillage as you just mentioned. So that's what I will suggest. Marty,
Just a quick question. Are you looking into drought resistant energy through that soil? Because, you know, not all farms are irrigated, but I think, you know, as we start to look at our you know, natural resources and so forth. So is drought resistance part of your work that you're doing?
so that's a good question. So what we're looking into when we're building organic matter, organic carbon, we see the water holding capacity increases, right? So there, in that place is where resilience comes in, right? So we are like trying to study that part too, see how resilient are the systems, right? Because with building healthy soils, probably in some cases will be like some trade-off, right? That probably we're building organic matter that probably will like, I don't know, decreasing the main cash crop yield like the first couple of years, and then, you know, we see increases, or like, you know, that we are strengthening the system later on, like after 3 years or so. So those are the dynamics that we're trying to understand and see which type of system should be, you know, recommended under like which conditions, right? For like which systems are good for like the western part versus the eastern part, and the central part.
So just to not put biosolids on wastewater treatment plant, and those go into dryland farms. And we're hearing from the producers that are working it that even during drought conditions, they're seeing an improvement in crop yields, and they attribute it to just the increase in carbon content in soils.
Right.
It's you know, just one of the benefits of
Building
fertilizer, but we're putting a lot of carbon out there. So, you know, they're starting to recognize that.
Yes, and those big jumps of organic matter we see like after adding manure, than more than like cover crops or like other residues that we can like add there. So yeah, I'm happy to hear that. Yes. Any other question?
You talked about soil stratification.
Right, yes, that's a good question. So with no-till, we see that accumulation right on the top surface on the first 10 centimeters or so. And we see that will be benefit, depends on like the system that you have in place. Also, if you come with like in some cases, like the type of planting that they use might like help out to like probably set up the new system, but stratification is something that occurs, yes, and might like, sometimes no-till, depending on the type of soil, might not be beneficial, might like later on prevent the main cash crop to like germinate. So we need to look into like what are we dealing with, like what type of soil, what type of system, and the history of that. So all depends on like, what is the aim of like, building organic carbon, like are we going into like, I don't know, reduce compaction or so on, go a few years no till and then going into mobile plow or like reduce till, so those kind of things. So yes, that's something that we don't see in the conventional till because everything is removed and then there's no stratification. Yeah, good point. So now then I ask you guys, if you don't ask me. So is this something that encourage you to do some soil health assessment? Yes, no. Is this something scary to like look into? Is it too much? I want to learn from you guys because it's great to have the perspective of the group regarding what I just shared with you. Yeah, go
I
ahead.
think it's important to do your soil test, know where your levels are at. I fully agree with your pH of your soils in reaction to chemicals and or fertilizer. The types of soils make a lot of difference in how you handle it and what you apply to it. We talked about anhydrous. There are some situations where they're talking about benefits or not benefits. I think it's a whole program that each farm is individual, and we don't want to do a broad spectrum across a lot of things and say this is what.
And you're right, there is no like one medicine for everybody, right? That's the tricky part. But the more that we're learning from everybody, what they're doing, like, what went right, what went wrong, like these type of learning communities really help us to like manage better, right? So as I'm telling you that this is a learning curve, but it's like steeper if you are like by yourself, right? Than when you are like in these type of settings. So I encourage you to keep, getting together, share, be open and share your experience of like, I tested these new practice and actually didn't work out, like reach out to UNL folks too, like, or we have the unbiased opinion, right? We're not selling anything. We are not encouraging you to like, buy something from somewhere else. But, if you have questions, reach out to us. If we can like, solve an issue or like, probably strengthen your project growth, that's something that, we could partner and like help out there. If you are interested in assessing soil health, let us know. But again, like this is a learning community, just like invite us to be part of, and together we can like, solve and like dive into like more complex questions. Because right now, as you can see here, this is not like just testing soil fertility. This is actually more complex. And it's like the same thing when you are like looking into your retirement investment. It's very complex, right? You don't know like how it works, but you need to like put some money in. Sometimes you lose, sometimes you gain something. But if you have the right people around you, you can start to learn the language, you can start to learn like what is the dynamics, what is behind these changes. So right now you guys raised the question about the soil pH, right? The acidity of anhydrous ammonia. So we know like, the dynamics or the chemistry or the nitrogen cycle or like all the chemistry behind that part, right? That we can talk about. But as the more that you get together, the more that we strengthen these learning communities, actually, the better that we would be, managing these issues that are like every time more complex than before, right? Because now we have climate change on top of us, right? And also the supply market and also fertilizer prices are just skyrocketing. And now we need to be more creative when farming, right? Because we need to like, now we're going back into like, okay, so let's talk about organic matter. Let's talk about manure, something that, in the past we were not working or just stop using it. So that's something that I would have there. Thanks. All right. Thank you very much.